here. Today, in this video, we're going to do something a little extensive. We're going to look at two power bricks, two power supplies, adapters. These both do USB-C. Now let's look a little bit at the specs here. Let's see if we can see them. So the one at the top is a name brand from Apple, USB-C power adapter. The one at the bottom is, let's call it an aftermarket adapter. It says it's a 96 watt. If we get zoomed in really close there. They're very close. They look almost identical. And then let's look at the regulatory side here. So we can see the Apple adapter and the off-brand one, they have very similar markings, but the Apple adapter actually says it's got a UL listing for Canada and the US. The off-brand adapter does not have any listing. They have an FCC certification, which generally means it doesn't emit a lot of electrical noise that might interfere with radios. Okay, what we're going to do in this video is we're going to be using the DL24P here to torture test these two USB power bricks. But because they're USB-C, it's a little more complicated. And we need to introduce, first off, well, obviously, we need a USB-C cable. That's not a big deal. That's not too complicated, right? But the other thing that we're going to have to introduce in order to kind of do anything significant is we're going to have to introduce this gizmo, because without this, we're not going to be able to really get above 5 volts. So let's see what happens first if we plug in the device and we don't have this thing. By the way, this is a power delivery trigger. So this is used to trigger the power delivery protocol in order to deliver voltages other than the default 5 volts out of the unit. So we'll have a look at how that works too. So first things first, let's plug in one of the bricks. We'll start with the name brand brick. We'll plug it in and we'll hook it up to the DL24P. We have the brick. It's hooked into the mains. I haven't turned it on yet. The USB-C cord is plugged into the board that adapts it to the DL24P. And now I'm just going to zoom in on the display here so you can see what's going on. And I'm going to flip the switch. And the switch comes on, and you can see that now we're producing 5.2 volts. So that's awesome. That could be like almost any power brick. It puts out fixed 5.2 volts. Okay. But this is a USB-C power delivery capable power supply. And it can output a whole bunch of other voltages too. And so the question is, well, how do we get those other voltages? Do we keep, well, as I mentioned, we need to introduce this power delivery trigger. And so what we're going to do is we're going to put this in circuit. It's upside down, but we're going to put this in circuit. And so we're going to plug the power brick in here on this side. We're going to plug this into the DL24P adapter board. And then we can use the buttons here, up and down, to request one of the higher or lower voltages. I mean, we'll clearly be going for higher. And power delivery, the standard, has a variety of different standard voltages that it can produce as outputs. So starting point is 5 volts. It can then do 5 volts, 9 volts, 12 volts, 15 volts, and 20 volts. Now those aren't exact numbers. I mean, the voltages tend to vary a little bit around those points. And so we'll see what comes out, but let's first insert this into the circuit and see what happens. And I apologize, the display is going to be this way, so it's going to be a little upside down. We'll just have to learn how to read upside down. If we look closely at the Apple brick, we see here that it says that it produces 20 volts at I think that says 3 amps. Let's try to zoom in a little more on that. So it's 20 volts at 4.3 amps, 9 volts at 3 amps, or 5.2 volts at 2.4 amps. Let's, for comparison, have a look at the off-brand. And we can see that the Apple brick also, it tells us that it's manufactured by Delta Electronics, which is one of the top power supply manufacturers globally. The off-brand power supply, it doesn't really tell us who the manufacturer is, but we see that it says it does 20.5 volts at 4.7 amps, 15 volts at 3 amps, 9 volts at 3 amps, or 5.2 volts at 3 amps. So we can see that this one does a different set of power delivery voltages that it makes claims for. Before I get into the stress test part, I thought it would be interesting to see how these power delivery power supplies work when they are overloaded and compare how they work with the way a more traditional power supply works when it's overloaded. And so we saw in an earlier video how typical power supplies that only produce 1 voltage, non-power delivery supplies, we saw how they behave. So let's have a look at how these power delivery supplies and operate. So I'm going to start with the off-brand power supply. So I've got it plugged in, now turned on, and we can see that a little bit of communication, 5 volts. So let's zoom in to the display. Okay, now I'm not going to use a temperature probe, and so let's see what happens. We're going to set this up for the rating that the supply has for 5 volts, which is 3 amps. So put 3 amps in there, and we'll start it off, and we can see that it's running quite nicely. 3 amps, 5 volts, almost 15 watts. And so what we want to do now is we want to say, okay, let's go beyond spec and see what happens. Now keep in mind that the power supply can produce quite a lot of wattage, but it's got limits to what it's going to do at the various voltages. So 3.1 amps, still not much of a problem. 3.2 amps, it's all fine. 3.3, all fine. 3.4, all fine. 3.5 is good. 3.6. Now at 3.6, you can see that the power supply is behaving in a certain fashion where it no longer can, it's no longer going to produce kind of a stable voltage, a stable output. And so, and we can see, based on the fact that the power delivery trigger is kind of resetting, that the power supply is kind of itself kind of cutting out because the current draw is too high. Now let's kind of drop this down at 3.5. At 3.5, once again, it's happy to re-engage. And so we can see that the way given the way that the voltage is jumping around from 4.8 volts to 4.4, there you saw it kind of fell a little too far. Okay, so even at 3.5 amps, it has some difficulty kind of running in a sustained fashion. Let's kind of go down one more. At 3.4 amps. Okay, the telltale was the way the voltage was jumping around at 3.5 amps. Okay, but we can see that at 3.4 amps, we've got a pretty stable voltage of 4.9 volts most of the time, and we're getting about 16, almost 17 watts of power output. So that's the off-brand supply. So let's turn that off. Now let's switch over to the Apple supply produced by Delta. Okay, so turned on. Okay, it's producing 5.2 volts. Now, the Apple supply, it's actually not rated to run at 3.4 volt amps. Its rating is 2.4 amps. So let's get into that 2.4 amps and be ready to adjust. So 2.4 amps, 5.2 volts. Okay, so it's running, it's fairly stable. It's producing about 11.5 watts. So quite a sort of a lower wattage output on the Apple supply. Now let's see what happens as we bump it up. 2.5, still good. 2.6, still good. 2.7, still good. 2.8, still good. 2.9. What I'm looking for is not just a voltage drop, but I'm looking to see if the voltage starts to sort of jump around wildly. 3 amps, so we can see even though it was only rated for 2.4, we can go to 3 amps. 3.1, still fine. 3.2. The voltage has dropped from 4.7 to, well, just below 4.7, but it is staying stable. 3.3, the voltage is still stable. 3.4, okay, 3.5, and that's where this power supply says, okay, that I'm really not going any further, and it also, as you can see, the power delivery circuit here is off, so there's no current flowing. So let's dial this back to 3.4. Let's see if it'll re-engage at 3.4. So there you have it at 3.4. A little bit of time for the protocol to work out, but it can re-engage and it can operate at 3.4. So quite a lot of variance between what the supply is rated for and what it's capable of. So the Apple supply is rated at 2.4 amps, or for 2.4 amps, but it'll go all the way to 3.4, so it'll go a whole amp higher, which is almost 5 watts in terms of what the output translates to here. On the other hand, the off-brand supply, it starts out at 3 amps, is what it's rated for, not quite as much variance. So what have we seen here? Well, we see, first of all, that these supplies, when they kind of get too far past their rating, they essentially just cut out, and so that tells us that devices should be well behaved if they're power delivery devices and they're making use of the power, because if they go off, or if they go beyond the capabilities of the power supply, the power supply is just going to kind of cut out, and that's just going to be irritating. But we also can see quite a lot of sort of extra headroom between these, and it's not clear whether it's just because In a sense, they're both capable of delivering about the same amount of power, but at the same time, the Apple made by Delta power brick was able to deliver, it's spec'd to 2.4 amps, but it was able to go much higher, whereas the off-brand was spec'd to 3 amps and not able to go too much higher. So is that just on the Delta side? Were they being more conservative about things, or was is it just a more capable unit overall? Next thing we're going to do is we're going to go through the overall stress test, where we're going to kind of take both of these to their maximum wattage rating, or close to the maximum wattage rating, let's say, because they don't have the same maximum wattage rating. And we're going to see what happens when we run them at their rated maximums for a long period of time. We have the Apple power supply hooked up through the power delivery trigger, and we can see it's set up to deliver, it's delivering 20 volts, so a little bit more accurate in terms of the voltage being delivered. Now let's see what happens as we start to run up the load here. So this is an 87 watt adapter, so I'm just going to start this off at 4 amps. Okay, and so at 4 amps, no problem whatsoever. Let's zoom in a little bit on the display there. 4 amps, no problem whatsoever. Now let's try to bump up the current draw, and let's see what happens as we hit the limits. Oops, wrong direction. 4.4. So that's effectively 87 watts. So that's sort of the spec limit for this load at this point. All right, so I've hooked up the external temperature sensor, and you can now see, instead of having a blank readout, I actually have a number displayed there. And sorry, I need a magnifying glass to see it from where I am. So we can see that that's showing about 27.3 degrees Celsius. Like I said, I'm going to leave that run for, well, let's say half an hour, and we'll come back and we'll see what the temperature is like. Make sure that it's still continued to run through this whole process. That's now been running for about an hour, and the temperature, in terms of the external temperature, has stabilized at about 45.3 degrees Celsius. Once in a while it comes up to 45.6, and it goes back down to 45.3. So that's kind of a stable point where it's able to kind of maintain its temperature, and it's not running above that. And also the internal temperature, although there's some active cooling going on here, the temperature of the controller in here is pretty stable at about 45.8 degrees Celsius. And so, I mean, that's a good sign. And I mean, I probably wouldn't expect much less from the Apple unit. So let's turn this off now. Okay, and it's just going to run a little longer to cool itself down, because it's been pulling down quite a lot of energy. So it's going to cool itself down. And then we're going to plug in the off-brand unit, and we'll see what kind of temperature it runs at. Based on specs alone, this third-party supply, or off-brand supply, is supposed to be able to handle 96 watts, but that would kind of create a bit of an incomparable scenario. So I'm going to run it at the same level as I ran the Apple supply. So I'm going to turn that on now. Now you can see, as a starting point, right, the temperature has kind of lowered here. So this temperature is down to 23.9 Celsius on the external sensor, and the internal sensor is about 29. It's not running, not surprising. So we're seeing On the off-brand supply, we see a slightly higher voltage. I'm not going to change the current, so I'm going to leave the current at the same setting. Because the voltage is a little higher, the wattage is going to be a little higher too. Okay, so it's now running at the same sort of level of draw, 4.4 amps, which is what I was running the other one at, or the Apple one at, in order to get the 87 watts for the Apple, or just about. So this is also, now that there's a load, at about 87 watts, so a little bit below what the spec says. We can see that the temperature on the device is 40 degrees and climbing, whereas the temperature on the power brick itself really hasn't changed much yet. We're just getting started. So I'm going to let that run for about an hour, and then we'll come back and have a look at where we are. The test's been running for a little over an hour now, and in that time, well, it's run pretty well, but the temperature on the external sensor now for the power supply is, I think that says 58, yeah, 58.4 degrees Celsius. So that's quite a lot hotter than the Apple supply. It's pretty, yeah, it's pretty warm to the touch there. In fact, in some places, I have the sensor mounted on the side, but in some places I really don't want to hold on to it because it's that hot. So so clearly we can see a difference between the capabilities of the unit from Apple and the off-brand unit itself, running quite a bit hotter, even though I'm running it below its specified load. If I were to run it, I'm sure if I were to run it at its specified load, it would be even hotter than that. This is the last of the DL24 series videos that I'd planned to produce. I've gone through a lot of the operation that this can produce. I've done basic operation, advanced operation, configuration, comparisons between the two different models of the DL24, battery testing, power supply testing. So I've done a lot of variants, but in a sense, there could be more. There could be other things that people are interested in seeing. So if there's some other sort of workflow or other kind of usage of the DL24 that you think might be interesting, please leave a message in the comments down below. And aside from that, thanks very much for watching these videos if you've stuck through to the end. If you've enjoyed these videos, please do subscribe to my channel, and please give this video a thumbs up. Bye for now.